Hi everybody, this is problem 7.5.35 or number 12 on the chapter 7 homework. So just to help us, I put a couple of formulas over here on the right hand side. I actually copied and pasted those right out of the question help. If you're wondering where I got them, they're also in the textbook. Anyway, so a golf club currently has 400 members that pay annual dues and to play golf on the course. Historical records show that 38% of members use the course at least once a week during the summer season. To verify this, a random sample of 100 members was selected. So again, I just have to start with what I know, and then I can kind of build from there. So I'm going to say big N, or the population, is 400. And little n, or the sample, is 100. And then I know that P, or the proportion of the population, is 0.38. That's from our historical records. So the first thing we have to do is calculate the standard error of the proportion. And the formula I have up is calculating the standard error of the proportion when we have a finite population, meaning in essence that our sample size is more than 5% or so of our entire population. In this case, we're going to have to use this finite population correction factor. That's this portion of the formula, because our sample size is actually 1/4 or 25% of the total population. So still, what I'm going to do is I'm going to calculate, just for simplicity using Excel, I'm going to calculate the standard error of the proportion and the finite population correction factor separately. And then when I multiply the two times each other, that will give us the corrected standard error of the proportion. So to find my standard error of the proportion, I take the square root of the proportion. Whoops, I didn't start with an equal sign, sorry. Of the proportion times 1 minus the proportion. And we divide that by little n, or the sample size. So that's our standard error of the proportion uncorrected. Then to calculate our finite population correction factor, this part right here, we're going to take the square root of our population, or big N, minus our sample size, and divide that by, well, this is all within the square root still, our big N minus 1. So our corrected standard error of the proportion then is just the standard error of the proportion times the finite population correction factor. All right, so that should be our answer for this first one, the standard error of the proportion. Wants 4 decimal places, so 0.0421. So now it wants the probability that 34 or more members from the sample use the course at least once per week. So to find that probability, the first thing we have to do is we need to find P bar, or our sample proportion. And so in order to do that, we need a value of x, and that's what this 34 is. It's our value of x. So our P bar, or our sample proportion, is going to equal x divided by little n, or x divided by our sample size. Once we do that, we can find the z-score of that proportion. So I'm going to call this z sub p. That's this formula right here. So this is going to equal our P bar minus P divided by the standard error of the proportion, which means the corrected standard error of the proportion that we calculated earlier. So there's the z-score for that x value of 34. So now to find the probability, remember if we use norm.s.dist, we use s when we're talking, our units are z's, gives us the z-score. We say true. So the probability that it is less than that is 0.17. So the probability that it is greater is going to be 1 minus the probability of less than. So the probability of 34 or more members from the sample is, what does it want? 4 decimal point 8290. All right, now it wants the probability that between 30 and 40 members from the sample use the course at least once per week. So here's how I'm going to do that. I'm going to need to take the probability that it is less than 40. I'm going to subtract the probability that it is less than 30, which will give me the probability that it is between 30 and 40. So to find the probability that is less than 40, I'm just going to replace x here with 40. And then right here is my probability that is less than that. I'm going to copy that, and I'm going to paste special here, or not paste special, I'm just going to paste the value. And then to find the probability that is less than 30, I'll replace x with 30. I'll take my probability that is less, copy that, and paste the value. Whoops, I did something weird. That is really being strange. Make sure that's right. Yeah. So the probability that's between 30 and 40 then will just be the probability that it is less than 40 minus the probability that it is less than 30. So it looks like we've got 0.6540. All right. So the last question is, if 50 members from the sample use the course at least once a week, does this support the historical records of course usage? So I'm going to come up here and replace x with 50. Whoops, not 510, 50. There we go. So now the probability that it is less than that is 99.78%, which means the probability that it is greater than that is 0.218%. So does this support our historical findings that 38% of members use the course at least once a week? And the answer is no, because we're way above that. So we're going to say no, since the probability of obtaining a result this large or larger is 0.0022. There we go. So again, I hope that was useful. And again, as always, don't be afraid to reach out if I can help in any other way.